All right, so the video just stopped for no reason, but it was a good stop. All right, so then let's continue for our question 2. All right, so for question 2 is a very classic question in the medical field, right? So we are talking about the sensitivity and specificity for some tests like in the COVID period, right? So we have our COVID tests. So these COVID test results are accurate or not accurate, right? So actually we use the probabilities to check the accuracy. All right, so here we are not using the COVID tests, right? So actually we have other tests. Right, so we say the ATCs are required to undergo a periodic random drug testing. All right, a simple low-cost urine test is used for the initial screening. So it has been reported that this particular test has a sensitivity and specificity. Right here, sensitivity and specificity of 0.96 and 0.93. All right, so you will see these two words very, very frequently if you work in the future, if you work in the medical field or medications or any let's say healthcare fields. All right, so you will see these two words almost every day. All right, so what does the sensitivity mean and what does the specificity mean? All right, so this means first for the sensitivity. All right, so this means that if there is a drug use, then the test will detect it 96% of time. And if there is no drug use, then the test will be negative, right? Will be negative 93% of time. All right, so then based on the historical results, the FAA report that the probability of the drug use at a given time is approximately 0.07. So draw a probability tree for this situation. So here I just gave you a hint because this is your first time to set up a probability tree. So just in case you don't know where to start. All right, so here we say we want to set up with did they use the drug or they didn't use the drug, right? So then next case will be if they use the drug, then what is the test result? It is positive or negative. All right, so if it is not if they didn't use a drug, then the test results are positive or negatives. And then of course we want to go further for joint probabilities, right? So then the structure will be what? Will be all the testers, right? So all the let's say all the observations need to get this tested. All right, so then what? Then you will have two cases, right? So they either use the drug or didn't. Let's say just to use this one as for short. All right, not use the drug. All right, yes or no. All right, okay, so then what? Then we say if they use the drug, then they may have a positive result or a negative result, right? So if they didn't use the drug, it is also possible to get a positive result or a negative result, right? Okay, so then what you need to do is try to find all of these information and fill out each probability on each track, and then also the last step, calculate the joint probabilities, right? So I think the only thing you may get confused is, let's start with this one, right? So what is the probability using a drug? We say the FAA report that the probability of drug use at a given time is approximately 0.007, right? So that means we do have the probability of using the drug, which is 0.007. Now the problem is, what is the probability not using the drug? What do you think? We say these two are just only two possible outcomes, right? So then their probabilities should sum to 100%, right? Or 1, right? So then if this probability is 0.07, of course the other way will be 0.993, right? So then similar idea for the second step, right? These two steps, right? So then you need to try to rate this instruction and see where to put this 96%, where to put this 93%, and then what are the other side of the percentage or probabilities. All right, okay, so I think once you have this probability tree, then the next two questions should be easy, right? So then we say, what is the probability of a positive test result, right? So this positive test result will be, how many cases do we have? This is positive result, this is positive result, right? So that will be the sum of these two cases, right? And then the last one, find the probability that given the test is positive, then what is the probability it is truly used the drug, right? So that means what? That means out of these two positive cases, which case is really used the drug, right? So that will be very similar case with this example, right? So once you understand this example, then the two questions should be easy for you. All right, okay, so I will just stop here and continue with the next application for the market basket analysis.